In today's video, we'll be exploring 10 interesting facts about our amazing universe. The universe has always been a curious place for many of us. It is made of trillions of stars, galaxies, black holes, enormous clouds of gas, and many other fascinating things. Welcome back to FTD Facts. I'm Sarah Carvalho, and today I've gathered 10 interesting facts about the universe, which I know are sure to interest you. Coming up at number 10, it was hot when it was young. The most widely accepted cosmological model is that of the Big Bang. This was proven since the discovery of cosmic microwave background radiation, or CMBR. Although strictly speaking, no one knows exactly what banged, we know from extrapolation that the universe was infinitely hot at birth, cooling down as it expanded. In fact, even only within minutes of expansion, scientists predict its temperature to have been about 1 billion Kelvin. Moving backward to 1 second, it is said to have been at 10 billion Kelvin. For comparison, today's universe is found to have an average temperature of only 2.725 Kelvin. That's crazy, right? Up at number 9, we have the fact that it will be cold when it grows old. So we're seeing the opposite effect here. Observations made especially on galaxies farthest from us shows that the universe is expanding at an accelerated rate. This and data that show that the universe is cooling allows us to believe that the most probable ending for our universe is that of a big freeze. That is, it will be devoid of any usable heat energy. It is due to this prediction that the big freeze is also known as the heat death, or the death of heat. Accurate measurements made by the Wilkinson Microwave Anisotropy Probe, or the WMAP, on the current geometry and density of the universe also predict such an ending. Now, did you know that the universe has a diameter of over 150 billion light years? That's insane. Current estimates with regards to the size of the universe pegs it at a width of 150 billion light years. Although it may seem peculiarly inconsistent with the age of the universe, which you'll hear about next, this value is easily understood once you consider the fact that the universe is expanding at an accelerated rate at the same time as it is aging. Now, let's talk about how old the universe is. Well, it's 13.7 billion years old. And if you think that's amazing, perhaps equally remarkable is the fact that we know this information to be true better than 1% precision. Now, how can we be so accurate in these statistics? Well, credit goes to the WMAP team for gathering all the information needed to come up with this number. The information is based on the measurements made on the CMBR, or the cosmic microwave background. Older methods that have contributed to confirming this value include measurements of the abundances of certain radioactive nuclei. Observations made on globular clusters, which contain the oldest stars, have also pointed to values close to this. Now, we know that the Earth is not flat, but did you know that it's quite probable that the universe is? Well, based on Einstein's theory of general relativity, there are 3 possible shapes that the universe may take: open, closed, and flat. Once again, measurements by WMAP on the CMBR have revealed a monumental confirmation. The universe is flat. I mean, I had no idea. This is probably the biggest revelation in this whole video for me. Now, combining this geometry and the idea of an invisible entity known as dark energy coincides with the widely accepted ultimate fate of our universe, which, as stated earlier, is the big freeze. Now, up at number 5 in the halfway of our video today, we look at large-scale structures of the universe. Considering only the largest structures, the universe is made up of filaments, voids, superclusters, and galaxy groups and clusters. By combining galaxy groups and clusters, we come up with superclusters. Now, that's a mouthful. If you want to know what each of those individual things are, you're going to have to do some research. Some superclusters, in turn, form parts of walls, which are also parts of filaments. The vast empty spaces are known as voids. The belief that the universe is clumped together in certain parts and empty in other parts is consistent with measurements of the CMBR that show slight variations in temperature during its earliest stages of development. Now, did you know that the universe is made up of tons of things that we can't see? Well, different wavelengths in the electromagnetic spectrum, such as those of radio waves, infrared, X-rays, and visible light, have allowed us to peer into the cosmos and see huge portions of it. Now, unfortunately, an even larger portion cannot be seen by any of these frequencies. And yet, certain phenomena such as gravitational lensing, temperature distributions, orbital velocities, and rotational speeds of galaxies, and all others that are evidence of a missing mass justify their probable existence. Specifically, these observations show that dark matter exists. Another invisible entity known as dark energy is believed to be the reason why galaxies are speeding away from each other at an accelerated rate. Now, you might be surprised, but there is no such thing as the center of the universe. Nope, contrary to the popular phrase we like to jokingly throw around, the Earth is not the center of the universe. In fact, it's not even the center of the galaxy. And no, again, our galaxy is not the entire universe, neither is it the center. Don't hold your breath now, but the universe actually doesn't have a center. Every galaxy is constantly expanding away from one another, so it would be very difficult to calculate a constant center. Now, this next fact might be obvious given the information we've shared throughout the video, but galaxies are actually rushing to be as far away from each other as possible. As mentioned earlier, galaxies are rushing away from each other at increasing rates. In fact, prior to the findings of most recently gathered data, it was believed that the universe might end in a big rip. That is meaning that everything down to the atoms would be ripped apart. Kind of sounds scary. This idea stemmed from this observed accelerated rate of expansion. Scientists who supported this radically catastrophic ending believed that this kind of expansion would go on forever and thus would inevitably force everything to be ripped apart. And all the way down at number 1 today, our final fact of today's video is that we must study structures smaller than the atom to understand the universe. Ever since cosmologists started to trace events backward in time based on the Big Bang model, their views, which focused only on the very large, got smaller and smaller. They knew that by extrapolating backwards, they would be led into a universe that was very hot, very dense, very tiny, and governed by extremely high energies. These conditions were definitely within the realm of the particle physics or the study of the very small. Hence, the most recent studies of both cosmology and particle physics saw an inevitable marriage between the two. All right, friends, this brings us to the end of our video on 10 interesting facts about the universe. I hope you enjoyed this video as much as I enjoyed putting it together for you. It's always cool to learn about and explore new ideas, concepts, and facts about the universe we live in. Now listen, I know I use some big words, some very scientific words, so feel free to research and learn about what these words mean and how they relate to the universe. Now, I want to know about you. Were you surprised by any of the interesting facts I shared? Join in the conversation below and let me know your thoughts. Also, don't forget to like and subscribe and ring that bell to stay updated on all future posts. And we'll see you right here next time for more facts. See ya!